I got an email from Iris Dynamics today about the force feedback yoke. They're not far from entering production. They've just released a video with a pre-production yoke being demoed. Well, I never thought this day would come, but about a week ago I got this. This is the long-awaited Iris Dragonfly force feedback yoke. Now it may look like a CH Eclipse yoke to the untrained eye, and that's because, well, I suppose it is in a sense. This yoke ships without a handle, so you need to make your own arrangements for a handle. I say it ships without a handle. The Kickstarter backers do receive a handle of sorts, officially referred to as the basic Kickstarter handle. And you know, basic is the word. It's a demonstration handle, essentially, that you want to throw in the bin right away and replace with something more usable. It does have a circuit board inside which you don't want to throw in the bin. This controls, you get two buttons with this yoke. They're two rocker switches, spring-loaded rocker switches, designed for controlling the trim and one other thing. You want to keep, if not the switches, you want to keep the circuit board. That has an RJ11 connector that plugs onto a flying lead that comes out at the end of the shaft. But anyway, I'm not going to say too much about this yoke because I am going to do a proper review of it at some point. At the moment I'm just trying to get used to what it does to the sim. So I'm just going to give you a very brief look at it and maybe fly it around a little. So in terms of the handle, the possibilities are you could stick with the basic Kickstarter yoke handle. If you buy one of these new, you won't get that handle. There is a developer version of this yoke available at the moment at a reduced price. Now I say reduced price, it's still about $1,500 US, no sorry, Canadian dollars, and you get the basic handle with that as well. But otherwise you can specify, if you buy one of these new, you can specify a PFC handle. That adds $600 to $850 US dollars to the price, depending on which handle you opt for. You know, that's just taking the price of this thing into the stratosphere. So what most people seem to be doing is taking their old Cytec or CH yoke. The Cytec Cessna yoke is a good donor for this. The handle's quite good. It's a nice chunky solid handle with a metal skeleton inside of it, and basically throwing away the rest of the yoke and using the handle for this. And of course you get to, as I've done here, retain all of the functionality of the handle if you salvage the electronics from inside the CH yoke or the Cytec yoke if you choose to use that. So what I've managed to do is I've mounted this, and actually the CH controller board is inside this handle as well, and this one USB lead, I don't know if you can see that, goes from that controller board and just is plugged into a USB socket. So just a few headlines of this yoke. Force feedback, what does that do? Well, I'm going to go into that in more detail in my review video. But the first thing it means, you can see the yoke moving in the cockpit here as well. But one of the first things you're going to notice is in the rest position the yoke is fully forward, and that's because it's simulating the software is simulating the weight of the elevators. You know, that's just something that you don't get with your basic two springs in a box yoke. Something else, two things of note. You're going to notice, rather like in my Cytec Cessna yoke review, we've got a full 180 degrees of travel in this yoke. It's actually quoted as 200 degrees, so it's more than 180 degrees. So that's very unusual in a desktop yoke, and it makes for a more realistic package. Don't forget, what we're aiming for here is, you know, we're not turning this into an arcade game by giving all sorts of weird and wonderful special effects. We're striving for realism at every step of the way. So we've got elevator weight, We've got 200 degrees of travel, but there's something that you might not expect. We don't have any centering on the yoke, but we don't have any centering when we're at a standstill. But what you're going to notice once you're on the move is that centering force emerges as we pick up speed, because really that centering action is not artificially induced by a spring in a real aircraft. It's actually a consequence of the airflow resisting the displacement of the ailerons, and likewise the elevator. So let's go for a ride.
Kilo Romeo India, Vector, Airport Information, Hotel 1620, Zulu, weather, wind 158 at 11, visibility 5, sky condition 800, scattered, ceiling 3000, overcast, light, rain, temperature 12, dew point 12, altimeter 2999, advice on initial contact, you have information, Hotel, Kilo Romeo India.
Now one of the things you might notice if you're looking is the yoke's moving there as we go. Now this is in the realm of special effects to some degree. We do get some special effects on the ground. Cornering forces are transmitted through a roll movement of the yoke. Now whether that's realistic or not doesn't matter. You get some feedback on the cornering. As we go, we're going to get bumps. Again, it's a sort of passable simulation of some kind of bumpiness. We also get forces when we brake. But the main thing to notice when we go through the takeoff, remember, is we're in the elevator's dead position at the moment. So the weight of the elevators is pulling the yoke forwards. As we get up to takeoff speed, what you should notice is and I'll try and keep my hands off, the yoke should come back as the elevator moves in the airflow. I'll trim up a little bit so it might lift off by itself if I'm lucky. Okay, so here we go, experimental takeoff. I'm controlling the rudder in case we leave the runway by mistake. We do have a little bit of a crosswind from the right. So the yoke's moving back on its own. It is juddering, but you can't really see that. I can see it. There we go, taken off. And the yoke's now more or less in the central position. And we have... What you can't see is the resistance that I'm feeling to the rotation of the yoke there. I'm going to put it on autopilot, indicated airspeed hold, heading hold. So I'm going to climb straight ahead at about 90 knots. Something else you can see, if I change the heading, you'll see the yoke is following the autopilot. And it's doing that in pitch as well. Now there are some problems with that which I'll get to when I review the yoke. But if we come off autopilot, and what I'm going to do is I'm not going to complete the flight. I'm going to come back down and maybe do an approach. Of course I've gone into the clouds, which doesn't help. And all the while I'm feeling resistance on the yoke, significant resistance compared to a sprung yoke. But more than that, it varies with the speed I'm flying at. So at the moment, I'm flying pretty slow. That resistance isn't too much. And what I'm doing now is, I'm flying the downwind, I'm trying to trim it straight and level. And this is different to a regular sprung yoke as well. There's a big dirty cloud in front of me, that's not good. What I'm doing is I'm putting the yoke where I want it to hold the attitude, and then I'm trimming until I feel that I can let go of the yoke, and it'll stay where I put it. I'm very high for the approach here, but that's okay, because we want to check this yoke out in the flare. 80 knots, more or less, 30 degrees of flaps. I'm using the HUD for now because it allows me to keep looking ahead without glancing down at the instruments. Good approach speed. So we've got less resistance on the yoke now because the speed's lower. 75, and we're going to start to flare about now. Just trying to keep it flying. There we go, we've got a bump through the yoke on touchdown. And if you watch the yoke now, I'm going to put reverse thrust on and hit the brakes. You can see that yoke's, I'm not watching where I'm going here, the yoke's snatched forwards. And that's, again, that's a special effect, that's simulating, then it's stopped now. The moment we've stopped, it's simulating braking, and the moment we stopped, that simulated force stopped as well. So that's the Iris force feedback yoke. We've now got it installed in the Twin Otter cockpit. I'm still getting the hang of this. It does make flying the Twin Otter different, certainly different. That's that's where I'm at the moment. You know, there are some limitations of the software that drives this force feedback, and you know, there is a certain amount of compromise inherent in using that software, but for now I think we've moved a step closer to a more realistic Twin Otter. So watch this space.